you are facing around 10% energy loss in your compressed air utility in your industry, and how can you reduce it now? It is more focused towards the compressed air generation and especially in the compressor house. Let us go in depth. Bureau of Energy Efficiency guidebooks always gave a guidance to us or to all the energy managers and auditors regarding the compressed air utility, and for every 2500 Pascal pressure drop across the suction of the compressor, especially due to the choked air intake filters, the power consumption increased by 2%. This is the thumb rule. This is given for guidance only, but tropicalizing the needed for the compressor, this is more important. Tropicalizing the compressor is needed for the sustainable health of the compressor, and you please check your full air delivery when the filter is choked. Coming to the case study of 110 kilowatt, this is supposed to deliver around 712 or 720 CFM as the rated delivery. With a clean air intake, it gives almost 712 CFM as per the flow monitored and trended and recorded, as you can see the bottom graph. The same compressor with the choked air intake filter could deliver only 617 CFM only. So when the process demands full compressed air flow from the compressor, this choked air intake filter drops the flow by 13%. So how to restore the full air flow now? As it that is what we have to see, how to restore the full air flow from the compressor. The compressor air intake delta P at 2700 Pascals and the average flow is only 617 CFM. You can see the maximum CFM, average CFM and the minimum CFM, and you can see all the field study and the recordings. Kind courtesy Sindhan Technologies Coimbatore, they have given this study to during our post audit energy audit in the industry. You can see the graph that is totalized for a period of half an hour, 1 hour per shift, per day and per month to arrive at the SEC or the kilowatt per CFM for the given compressor. The compressor feels or faces sad starved air delivery at the suction instead of a free air delivery. The first step what you have to take is, it needs a digital Pascal meter. You have to install that first. The second step is, after installing the digital Pascal meter, you have to reduce the air intake filters delta P. So go for a 2-stage pre-filtration air filter, pre-filter, daily cleanable inside and outside the V-type filter, and the next stage is daily washable 2-stage polyurethane, is almost around ½ inch thick, pre-filter to reduce the air filter, main air filter choke. These are all the daily routinely maintainable solutions by the compressed air user. The compressed air header, flow meter and the totalizer is a must to quantify the energy losses at the compressor inlet as well as from the delivery of the compressor. This can only give the average SEC, the kilowatt per CFM. Energy monitoring in the compressed air is complete only when the package input kilowatt and the delivery airflow in CFM at watt bar to be recorded and trended to arrive at the SEC. Here you can see the graph. 45 kilowatt screw compressor consumes around 48 kilowatt to deliver 222 CFM at 5.8 bar. The watt per CFM is almost 0.22 kilowatt per CFM, 25% more than the rated kilowatt per CFM capacity. So we have to adjust to the compressed air generation here. The steps to correct the zigzag flow here. First step is to clear the air intake choked filter. It could be one of the reasons. The second step is relocating the pressure sensor from the compressed air hood to the immediate receiver to reduce the pulsations in the compressed air. The third step is replacing the timer based drain valve in the compressor hood and in the air receiver to zero air loss float operated drain valve at the receiver. If you don't have any air filter delta P Pascal display in your compressor console, you can install by yourself analog or digital Pascal gauge with a latchable alarm. It is costing only around 10,000 rupees only. Usually ignore the first stage energy loss at the compressor air intake. The user assumed this as a very trivial loss only. But in the compressor console, the air intake delta P displays around 006 bar, 0.006 bar, decimals getting always ignored by the user. The user can monitor daily if the final resolution of the reading in Pascal is shown to the user and not in bar. The OEM can update the display to fine resolution from bar to Pascal, and the user to add, if it is not there in the console, the user can add you can see the Magnehalic gauge, a differential pressure gauge plus a pressure switch for audio visual alarm in case of high delta P coming across the air intake. The compressed air parameters to visualize and comfort the compressor first. Compressor you should use the compressor in such a way that it is like a submersible pump working in air. The compressor, like the submersible pump which needs the water from inside, and always the water is also surrounding the pump to cool the pump. Like that, the compressor needs sufficient cool surroundings, ambient outside, as well as to suck inside at the air intake. Compressor house also needs a positive cross ventilation. Well ventilation is important here. The cool compressor delivers more air. Why I am just talking in terms of slogan? The slogans can be implemented in your compressor house. During night time, the compressor demand and the volume requirement will not be that much compared to the daytime, because the maintenance is more, schedules are more in the daytime than in the night time, and the temperature drops, ambient temperature drops. So, you can reduce the pressure setting by few percentage points. Let us say if it is from 6.5, you can bring it to 6.2 or 6.3, and you can achieve the energy savings daily also. A continuously run compressor delivers less than an intermittently run compressor. So, you do not plan to run your compressor continuously for 1 week or 1 month. You run it for every 4 hours conveniently and swap it to mains or standby as auto selection of compressor, and give intermittent cycle rest to the compressor for its sustainable health. The elbows or the sharp bends or the T connections are the silent killer in the compressed air distribution system. Plan to remove the above and go for long elbows and bends and 45 degrees conjoining bends in the T connections. Once you have done the piping corrections and implemented all the piping layout corrections, you can see the cutout settings can be adjusted to save energy further as such. We can also give adequate buffer tank or a air bottle or a longer pipe at the inlet of your pneumatic mini subheader at each of your machine, so as to reduce the overall main header pressure. The compressor user needs to be aware of the ambient air parameters surrounding your compressor. The variation in the moisture in the ambient air at various humidity levels, say from 50% to 80% is huge. It is almost double. You can see the graph at the bottom, the relative humidity at 50% and 80%. The kilogram of water vapor per hour for every 1000 meter cube per minute of air at 30 degrees, it is around 28 and 45. It is almost double. So, once you are trending the compressor efficiency as kilowatt per CFM for shift in daytime and night time, you can see the deviations. Accordingly, you can plan to correct the your compressor maintenance. The air compressor deliverable output is a dynamic process variable and always suited to the demands of from the types of the pneumatic load, and then only that decide your compressor flow and pressure. Your compressor utility delivers less airflow due to the following. One is, practically many of the large industrial compressed air users have realized this compressed air variation and have installed compressed air header flow totalizer meters, digital totalizers. Flow meter must be at the header after dryer to measure the laminar flow, and it is a cooled air flow from the refrigeration dryer. Thermal mass balancing type, in situ type flow meter can be installed at the header after the dryer, and this kilowatt per CFM when measured the above totalized input and output flows varies by 20% even in a well managed healthy compressor, especially in a bigger process plants. Kilowatt per CFM, what the industry assumes is around 0.16 kilowatt per CFM for its healthy compressor, but what is recorded in this flow meter, we find it is around 0.19, it is almost 20% more. So, where is the loss? You have to pinpointedly go and address the loss first. Tropicalizing the compressor, we installed the refrigeration dryer to double the compressor capacity. Let us say the compressor is around 100 CFM, we installed a refrigeration dryer of 200 CFM capacity. Similarly, talk to your OEM and go for double the size of air intake capacity for your compressor. This will sustain the compressor's full air delivery for a longer period. The compressor house also, especially the compressor, needs all round ventilation. So, keep your post air cooler inside the hood clean and dust free for effective heat transfer. Almost 70% heat rejection is happening across the post air cooler. That needs to be first attended, given a preference and priority to maintain the post air cooler, and by installing a digital temperature indicator with a high alarm provision on the air receiver, immediate receiver, this will give an alarm and immediately you can take the correction on the post air cooler. All these case studies have been discussed in these two books, Practical Guide to Energy Conservation and Management and Energy Savings in the Compressed Air Utility System. This is available in the Notion Press, and it is like sharing the knowledge to save our energy that is commonly available to us. And energy saving education is half done in the energy conservation. So, you go ahead with your energy conservation and please share with others for the benefit of all the others in the industry in your segment. Thank you. Thank you.